This is Dr. Frederick. We're looking at problem 1 in module 1. And for any problem that you have all this help over on the right. Help me solve this. View an example. You can see the part in the textbook at which this problem you can get information. And you certainly at this point should have read your textbook about ANOVAs. Because once you understand ANOVAs, then you can just come in and work this problem very quickly. Let's view an example. Here we have an experiment with 8 groups with 4 values in each group. Well, how many people are in our sample altogether? Well, 32. 32 is n. C is the number of groups 8. And so we can fill in all these degrees of freedom right away. In fact, we can do the whole table without any other assistance. But let's just say there's 8 groups. C is the number of groups. How would you know that? Well, you have to read your book, but you can also just go over here to view an example. Note that C represents the number of groups, and N represents the total number of values in all groups combined. So here for C minus 1 in our ANOVA table, we're going to have 7 degrees of freedom, right? Here we're going to have 32 minus 1 or 31 degrees of freedom, and 32 minus 8 is 24. So we'll end up with 7 plus 24 is equal to 31, and that'll make our first column there. So it just shows you how to do that. Continue. It shows you step by step how to work the problem. Okay. Right. Okay, so it says, okay, it showed you how to get 7, 24, and 31. Now, it says that the mean squared of among groups, usually this is between groups, or not between, but they come up with different letters for each publisher that makes this, but so they're calling it among groups, mean square among. Well, that's equal to the sum of squares among divided by the degrees of freedom. Okay, in other words, sums of squares, A divided by 7. So this value is this value divided by 7, so this value is 7 times 84, right? Because whatever this value is, which is what must be 588, divided by 7 gives you 84. So they want you to see that you understand the relationship here between all of these values on row 1. Okay, so let's continue. Right, it's 588 divided by 7 is 84. So in other words, 84 times 7 is 588. So you can fill that in. Okay, now we'll see, okay, how do we get sums of squares total? Well, 588 plus 336 is some value. It's 924. Okay, so that's our sums of squares total. We'll need to get this value, which will be 336 divided by what? 24. So 24 into that probably is what? 14. Right, so we'll fill in 14 there. What's our F statistic? Well, F is the mean square above divided by the mean square below. And so that's going to be 84 divided by 14, which probably isn't, well, what is it, 6? Okay, so our F value is going to be 6. So there's our table completed out there. And so I had a couple students tell me there was no examples in my stat lab, but there's very extensive examples like this that show you exactly how to work the problems. Okay, I'll do part 2 in just a second.